Hi, kids. Welcome to another enrichment in KNEX. I'm glad you've made it this far. Things are starting to get a little bit tougher, as you're finding in the enrichment. I'm beginning to demand a little bit more accuracy and consistency and that sort of thing. One of the things that I'm doing right now is I'm moving you into the process of figuring out the price of what it is you build. And that's really, really important, because as an engineer, you're always going to be conscientious of the price of something that you're building, because you want to make it feasible or economical to produce something. Okay, so money is always in the background of your mind. And then when you do get something built or invented, you need to figure out how much it will cost to put it into production. So this little lesson is kind of going to help you with your managing of the pricing of your KNEX items. And it will also go into perimeter, because when we talk about perimeter and we talk about building amusement park rides, like you can see in my background area at the Ferris wheel, and I like to always refer to this one right here, this crazy beast, the swing ride, we have to be aware of the size of things, especially if they're going to be put into limited spaces. We also have to be aware of their area that they're going to take up in terms of what it will require when it's non-operating, and what it will require in terms of operational area, because some things grow when they get turned on. In other words, they need room to operate. So anyways, what we're going to do in this video is I'm going to go over with you how to find the perimeter of things you make out of KNEX, and then how to price them out. Okay, now to price things out, you were given this page right here. Okay, and you should still have this. If you don't still have this page, you're gonna have to see me about getting a new one. You might have to earn a new one. But anyways, what you will see is on this page you have the item, the number, its size, and then its size in the metric system. So a gray rod would be 1 9/10 of a centimeter long. And then over here you have the unit price. Unit price means the cost of one item. Okay, just one item will cost you the unit price. All right, so keep that in mind. All right, now when you look at something like perhaps this, okay, this basic shape right here, what you would have to do is you would have to figure out the cost for all the parts. Okay, that includes the connectors and the rods. So what you would do is you'd say, okay, well, I have 2 blue rods. The cost of blue rods is 16 cents per unit. So you would have to take 16 and multiply it by 2. The same with the red. And then you would have to multiply the price of the red. And then you'd find the price of the connectors, and the price of the yellow connectors. If you look at your sheet here, yellow connectors are 23 cents each, which means you'd multiply 23 by 4. So once you've multiplied and calculated out the cost for each individual part, what you would do then is you would add those products up to get your total. Usually I don't ask for sales tax, but sometimes I do. All right. In this case, here's an example of another item that you would build and figure out a cost for. Now, in this one, you'd have to be really careful, because notice how we substituted a yellow rod for a white, orange connector, and white rod. Okay, so when you price this out, you would figure out the cost of one red rod, 1 yellow rod, and 2 white rods, and then the connectors, yellow, white, orange, and light gray. Okay, so that's how you'd figure out the cost for that. One that gets a little trickier. Okay, here's one that's a little bit trickier, this shape right here. Okay, so in this shape you've got a lot more parts. You'd have your yellow rods, and so you'd have to multiply the cost of a yellow rod by 2. You have your white rods. Okay, so you'd have to multiply your white rods, the cost, by 4, because you have 4 of them, and then you have your green connectors, and then you'd get the individual costs, and then you'd add them all up. Okay, Now, perimeter. Let's talk about perimeter. Okay, perimeter is the distance around an object. When you measure the perimeter or area of KNEX, it's not really 100% accurate, which is very realistic in terms of real life mathematics, because a lot of times when you're measuring stuff, it's not going to be easy to get the exact measurement. Our textbooks have a tendency to make you think that every measurement is going to be accurate and there's going to be 100% correct answer for those measurements. And in reality, that's just not true. In the real world, measurements come at you in many different ways, and even though you have really good tolerances, you're going to get slight variances in your measurements, okay? So sometimes the best you can do is to get as accurate as you can. Okay, so anyways, here is this rectangle, okay? Now, essentially, this is a rectangle, but you can see where, you know, the rectangle comes down here and then goes flopping out around there, comes down there. So technically, the perimeter isn't a rectangle, but when we talk about measuring the perimeter of a KNEX rectangle, we're talking about from here down to there, over to here, back to there, and to there, okay? So this gets tricky when you're trying to measure these distances, because you can't just measure to the red rod, because there's a bigger space than that on the outsides of our rectangles. So one of the things that I like to do with kids is I like to tell them that when you're using your ruler, we're going to usually always measure in centimeters, okay? So centimeters are measured on your ruler as the units. In between each of those are the millimeter measurements. All right, so 1 centimeter has 10 millimeters. 2 centimeters would have 20 millimeters. All right, so 1 centimeter has 10 millimeters. 2 centimeters has 20 millimeters. Now, when you measure, I'm almost always going to ask you to round it either to the nearest whole centimeter or half centimeter. Okay, so when I take this and I measure the perimeter, what I like to do is set up my ruler, okay? Set up my ruler so the measurement begins right at the edge of the circle right there, or slightly in the center. And then what I do is I get my length or my distance to the edge of the blue rod or the edge of the circle right there. Okay, so in this case, if you look at this, if you look down at it and see if I can get it zoomed in a little bit, the distance from this red rod down to here, I would give it right to there, which is about 15 and 5/10 of a centimeter. So this would be about 15.5 centimeters, but we'd say 5/10 because we're talking about the metric system. Okay, so in this case, when you look at it, we measured from the outside edge of the circle here to the outside edge of the circle there, okay? Or another good way of doing it is to simply measure from the outside of the blue rod to the outside of the blue rod, because you're only losing about a millimeter and a millimeter on each side, so you get pretty accurate. So if you look at that, you can see where I've started my measurements on 0, and I'm going to go all the way down through the center of this rectangle, and that will work because it's a rectangle, to get this measurement right here. And so if I bring that measurement up and let you see it, you can see that that is about 15.5 centimeters. So it's similar to what we got over there. All right, so when I calculate out the perimeter, I want to figure out 15.5 centimeters, 15.5 centimeters. So that would be 15.5 for both sides. But now I have these two sides to measure. So again, I would do the same thing. I would put my ruler on there, like so. And when I bring it down there, you can see where I'm measuring from. I'm measuring from the edge of the circle, and I'm going to the edge of the circle here. So I would call this edge this side, I would call that 8 centimeters, because there's 8 centimeters. Well, if it's a rectangle, we know that it's also a parallelogram, so opposite sides are congruent and opposite sides are parallel. Congruent meaning they're the same measurement. So whatever measurement I get here, I am also going to get here. So I have 8. So what I would do is I would have 8 plus 15 and a half plus 15 and a half. Or I could multiply 15 and 5/10 by 2, multiply 8 by 2, and then add those products together to get the perimeter. Okay? Now, triangles and stuff like this can be a little bit trickier. So when you look at something like this, okay, measuring it, you could, some kids are going to want to think they should measure to there, but a good focus point is to go from the inside of the circle to the inside of the circle to get your length. So I'm going to put my ruler on here like this, and notice how it's kind of centered right in there. So I'm going to adjust it so it's in the center. I'm going to make sure I measure straight down there. Okay? And then I'm going to measure right to about the center of that circle. Okay? So when I do that, okay, you can see that I'm getting about, from here to here, I'm getting about 10 and a half centimeters, or 10 and 5/10 centimeters. Now, I guess I could slide it like this and say that's a measurement of 10, or I could push it to the outside and say that's a measurement of 11. Either way is going to be acceptable for perimeter, and so you could then say, okay, well, I have two sides that are congruent, and I can just take my measurement. And in a situation like that, when you have the choice of 10 or 11, I usually go with 10.5 or 10 and 5/10 of a centimeter. That way I kind of account for how different people would measure. All right, the same with the side here. I would certainly put my starting point here, and you can see where I have my ruler starts right here, and then I would measure down to there. And in this case, it kind of looks like I'm going with about 15 for this distance here. If I went to the outside, it would be 15 and a half, but I didn't go to the outside here. I went kind of to the inside of the gray circle, so I'm going to kind of go to the inside here, and that would put me at about 15. So I would have 15 plus 10 and 5/10 plus 10 and 5/10, and that would give me the perimeter. Okay, all this stuff up around there and out around there, we don't really consider that a part of the actual structure. That's just kind of stuff that hangs out there because, we might not have parts like this that would give us a nice clean edge. So that's why we work with the centers. Okay, now here comes a trickier one. Okay, this shape can be really tricky. Okay, but what's neat is this distance from here to here is going to be the same distance from there to there. You just have a jog in here, okay? And if you looked at this, this would be a square, so there's some tricks here that you can do for figuring out the perimeter. But ideally, what I would do is I would measure from the center hole to the center hole, from center hole to center hole, to center hole to center hole to center hole. And then you can get that perimeter by adding this distance, this distance, this distance, this distance, and you can figure things out. Now, figuring out area for this is a little bit more difficult, but perimeter, you can basically say, okay, this is a square, this distance from here to here. If this white rod were out here, it'd be the same distance. If this white rod were here, it'd be the same distance as there. So you can even save some time by just taking this distance and pretending it's that distance. All right, so anyways, just to show you, I would put my ruler on here like this. Whoops, that's inches. Put my ruler on there like this, and you can see that from the outside to outside, it's coming in at about 11 centimeters. Okay, you can see that it's about 11 centimeters right there, which means this distance is going to be 11 centimeters. And sure enough, that's about 11 centimeters. Well, if this is half the distance from there to there, this should come in there somewhere around 5.5 centimeters. And oh, by golly, look at that. Right there at 5.5 centimeters. Well, if we know, If we know two white rods are equivalent to a yellow rod when connected, we know that this must be the same distance as that. And we know that this distance must be the same distance as that. So you can do all sorts of neat tricks when you're figuring out perimeter, okay? Alrighty, we're going to, now what I'm going to do is have you build the following shapes, okay? Here's the first shape that you're going to build, okay? The first shape is number 1, okay? Build this shape, figure out its perimeter, and figure out how much it would cost. Shape number 2, all right? Shape number 2 is this shape, all right? You want to build this shape, figure out its perimeter, and figure out its cost. Shape 3, there it is. Build this shape, this triangle, and figure out its perimeter and cost. Shape number 3. Shape number 4. Shape number 4. It's a little bit trickier, okay? You're going to figure out the perimeter of this shape and then the cost. And the last one is shape number 5. Shape number 5, okay? You want to figure out the perimeter and the cost. All right? Okay, kids, good luck with this. Remember, I'm going to be pretty fussy about accuracy on this one. Alrighty, good luck.